All right, we're starting chapter 11. We're doing the first two lessons, area of triangles, parallelograms, and kites. And a lot of this is going to be a review. There's just going to be a few added things in there that might be different from things you've done in the past. But for the most part, you should feel pretty comfortable with this material. All right, so perimeter. To define perimeter, it's the distance around a figure. The distance around a figure. And basically, you add the sides. Now, you don't include anything inside, it's only the outside sides. So if you've got a line in here, you aren't concerned with that. That's not part of the perimeter. It's 1, 2, 3, 4 sides right there. Okay, now area has to do with the space inside. So we're going to say it's the space covered by a figure. It's inside. So if we draw the same rectangle, I want to know what's inside, how much space that inside covers. All right, so we're going to work with perimeter and area of all these different figures. Do keep in mind, there are formulas for perimeter of certain figures, but don't get hung up on those because perimeter is nothing but adding up each and every one of the sides that are on the outside of the figure. So if you can remember that, there's no need to get hung up on formulas. All right, so we're going to start out with a square. All right, define the area of a square. It's just like the area of a rectangle. You multiply the two side lengths, but you might see it written S squared because S represents the sides. You have the length of one side times the length of another, and since all the sides are congruent, all you need is just the length of one side. You square it and you're good to go. And remember that S represents side. We don't use that for any of the other formulas. In the rectangle, you might see it written two ways. First way, you may see it written as the base times the height. And if you see this right here, the B, the base, and the height. But you might also see it written as length times width. So do note that your base would be also considered your length, okay? And your height might be considered your width. So either one of those works. Now, the height of a figure is equal to the distance between the bases. And that's why we refer to this as a base or the length. So your distance is always the distance between. And remember that distance, we're always looking at it as your perpendicular distance. It's never slanted. It's always perpendicular, just like the altitude of a triangle. That's what you're looking at, is perpendicular distance. So now then, in this situation, this is like a little two-dimensional figure so that you can kind of see how it works. If you were to transform a rectangle to form other parallelograms with the same base and height, notice we didn't change the height of this nor the length of the base. We just kind of slid each one of those over, okay? All right, your area of this rectangle is base times height. Well, over here as a parallelogram, it's still going to be the base times the height. In this situation, your height is the distance, perpendicular distance between the two bases. So the area of a parallelogram, we refer to it as the base times the height. You won't see it as length times width. But remember that B is your base and H equals height, and we're always looking at perpendicular height. It's the perpendicular distance between the two bases. So this is B and this is H. All right. Then, down below, we're going to talk about triangles. Now, you've seen these formulas before. It's nothing new, but just want to make sure that you understand the reason that the formula is the way that it is. Since a triangle is formed when we cut a rectangle or a parallelogram in half, the formula for the area of a triangle is half the formula for the area of a rectangle or parallelogram. So you can see here in this picture, this is a rectangle, and this is your base, and this is your height. And if you were to draw a diagonal to cut that in half, you would see that this rectangle was cut in half. And you have a triangle now formed from that rectangle. And so this area is going to be half of the original area of the rectangle. Same thing right here, and this kind of looks like a rhombus, but you've got your diagonal cutting this parallelogram in half, and so base times height, okay, and your perpendicular height right there, and then you divide it by 2 and you get the area of a triangle. That's why the area of a triangle is always base times height divided by 2. Now, on the formula chart for the EOC, you might see it written this way, or 1/2 base times height. And I never like writing my formulas this way because everybody freaks out when they see a fraction there in front of it. But you can multiply these together and multiply them times 1/2, or you can multiply them together and divide them by 2. It's the very same thing. All right, and so here's your triangle. Right here, this whole section down here is the base, and this perpendicular distance from the top to the bottom is your height right here. Okay, so be sure you understand it's always the perpendicular distance. Now, if you were to have a right triangle given to you, guess what? You've got your base and you've got your height right there. Anywhere you see those perpendicular lines, that's your base and your height. Okay, just going to practice some of these steps now on the back. Example 1, we're going to find the perimeter and the area of the polygons. Okay, so number 1's a triangle. And notice that you've got the lengths of the sides on the outside, but you also have the height of the altitude. That is not used in finding the perimeter. The perimeter is 17 plus 10 plus 21, which added together is 48 units. And one big faux pas of this problem is it doesn't have any lengths of measure given, so we're just going to use units, because one thing I want y'all to really be pay attention to is labeling units if it's in perimeter and unit squared if it's in area, because that's going to be important on the EOC. Area is equal to base times height divided by 2. So notice your base right here is 20 and your height is 8. Those are the two sides that create the right angle. Those are your perpendicular lines. So that is your base and your height divided by 2. So if we multiply that out and divide by 2, we're going to get 84 units squared. And be sure you put that that square mark there to show that we have that is area. That's how we know the difference between the two. All right, number 2, we have a parallelogram right here. So if we want to find the perimeter, the thing about a parallelogram is opposite sides are congruent. So if this side is 30, this side is 30, and this side here is 20. I can do a formula, but I don't care. I'm just going to add up all those sides. So 30 plus 30 plus 20 plus 20. That's 60 plus 40, or 100 units. All right, and then the area. Our area is our base times our height. If you use 20 for your height, it will be wrong, because that is a slant height, which is longer than the actual height of the parallelogram. And if we go back to this model right here, The reason why we use the perpendicular height is because if we shove these back in here, that would be the height of the rectangle. All right, so we've got the area is base times height divided by 2. Why did I put divided by 2? I do not know, because I just did a triangle. I'm going to mark that out. I have divided by 2 on the brain, but we don't want to do that. It's just base times height. And we get 510 units, and we're talking about area, so it's squared. All right, triangle again. Now, this is a right triangle. So we've got our base and our height here already, but we don't have the length of our base. But 2 ways to find out. Since it's a right triangle, we can do Pythagorean theorem, or if you go back and remember your Pythagorean triples, what's the length of this side? That's my horrible drum roll. It's 12. I don't want to do Pythagorean theorem. I want to know my triples to save me time. All right, so my perimeter of this triangle is 5 plus 12 plus 13, and that gives me 30 units. Then my area is base times height. Here's my base and height where I have the right angle. 5 times 12, and of course divided by 2 because it is a triangle. So that's 60 divided by 2, which is 30 units squared. And it's just a quinky dink that these happen to be the same. Don't get used to that. It happens occasionally. All right, next up, a trapezoid. All right, so we've got the height of a trapezoid is the perpendicular distance between the bases. All right, so right here is a really crummy example of that. Let's see, that kind of got off track there. So we've got a line that's perpendicular to both bases, and remember that these are parallel. Your bases are always parallel. This is base 1. This is base 2. Okay, and our formula is going to be this. Base 1 plus base 2 times the height divided by 2. All right, now what this is right here, this portion, that is the mid-segment formula. You know, when you add the 2 bases together and divide by 2, you get that mid-segment. All right, what this is doing, it's getting that mid-segment times the height, because what we have here is this area out here. So if we use this as our base only, we're getting the area of this space that doesn't exist. And if we use base 1 only, okay, we're eliminating this portion that does exist. So by using our mid-segment, we're able to incorporate this, the parts that exist within this region only. Okay, so that's the reason for that. And then of course, times your height. So it's basically the mid-segment times your height, if you want to look at it that way. Mid-segment times height. And that's what this is. Okay? And now we're going to talk about rhombi and kites. The diagonal lengths are used in the formulas for area of a rhombus and kite. These are a little different. You do have to memorize these. And, you know, I can't even remember. I know they weren't on the tax formula chart. I don't think they are on the EOC or STAR chart either. These other formulas are, but I don't believe these are. So what does that mean? If it is on your test, on a standardized test, they sometimes, I have seen them on tax, give the formula to you, but it sure didn't hurt to make sure you remember these, okay? And how they work out is we're taking diagonal 1 times diagonal 2, and we're dividing it in half, okay? Right here, we'll call this diagonal 1, and we'll call this one diagonal 2. Okay, so diagonal 1 is going to be orange, and diagonal 2 is going to be in pencil. Okay, so in pencil and in orange. There we go. All right, so that's all there is to it. And make sure you know that D is the diagonal. All right, and the kite is going to be the very same formula. Diagonal 1 times diagonal 2 divided by 2. All right, so we'll make diagonal 1 orange again. And we'll make diagonal 2, this diagonal. Oop, I did it in pen instead of pencil. That's all right. It's all good. I think y'all got the gist of it. Okay, multiply those bad boys, divide it by 2, and you are good to go. All right, now we're going to practice some of these down below. Here's some examples. Find the area of each figure. And notice I didn't talk about perimeter of these. Why? All you do is add up the sides. That's it. Okay, so let's take a look at area. All right, now this is a trapezoid, and it doesn't have to be an isosceles trapezoid. It's the average of the bases times the height. So our area is going to be base 1 times base 2 divided in half times my height. So 48 divided by 2, that will give us 24. Is that right? Oh, you know what? What did I do here? I said times. I don't times those. I add those because it's the average. What is going on in my head? So 6 plus 8 is 14. Divided by 2 is 7. And then 7 times 4 is 28. And since we are looking at feet, this is 28 feet squared. Make sure you put that square marking there or it will be counted wrong. All right, now our kite. They gave us the diagonal down here. They didn't draw it in here. But the diagonal this way, horizontally, is going to be 14. And our vertical diagonal is 6 inches. So our area is going to be diagonal 1 times, this is where I was thinking of times, 14 divided by 2. It never hurts when you're learning this to go back and write these formulas out and then plug your numbers in them just to make sure you don't get confused. Okay, so 6 times 14, oh geez, what's 6 times 14? 84, we'll say 84. And then 84 divided by 2, that's going to be 42. 42 what? 42 inches squared. Make sure you get that in there. All right, now our kite. Oh, nope, not our kite, our rhombus. Now notice this right here. See this little thing? That is only half of the diagonal. So the entire diagonal, we'll call that diagonal 2, is going to be 80 meters. And the entire diagonal 1 is going to be 60 meters. So make sure you pay attention to that. So our area is 80 times 60 divided by 2. Oops, forgot my 0 there. 80 times 60 divided by 2. Well, 8 times 6 is 48, and I've got 2 zeros after it. If I divide that by 2, I get 2,400 meters squared. That's my area. That sums up 11.1 and 2, finding perimeter and area of different polygons. Okay, and by polygons I mean triangles and quadrilaterals because we're going to get into more different types of polygons later on.